नमस्कार, मैं आपका आलोक रंजन. I have selected a topic today which is very crucial for you for this PT and mains also, because this news has been making round in the last 6 months newspaper. 6 महीने से ये बहुत important news बना हुआ है Madden Julian circulation, because it is connected to the polar vortex phenomena of North America and also the cold wind breaks which North America witnessed, and the heat waves of Europe, and also the changes in the monsoon and the dry and wet spells of monsoon. So this phenomena has attracted the scientists across the world and also the student of science, and especially we geographers are deeply interested into it because it relates to the weather condition and the intra-seasonal changes in the weather conditions, especially in the tropical region. Madden Julian oscillation has influenced the entire globe, and it has affected even the cyclonic formations, the tropical cyclones mainly, the cloud formations along equatorial belt, and the system of thunderstorms, also the high rainfall regimes at certain pockets along equator, and some low rainfall regimes. So it's a very interesting topic, it's a very complex topic as well, and it's very difficult to explain this particular phenomena in few minutes or say in the confinement of times. In 1971, Roland Madden and Paul Julian were the two scientists who first discovered the Madden Julian circulation, or the MJO, or the Madden Julian oscillation. Initially it was termed as Madden Julian circulation because initially it was believed to be an upper air near tropopause flow of cold air from west to east. Madden Julian circulation is connected to the INSO, or the INSO phenomena. INSO meaning El Nino and Southern Oscillation. But there is a marked difference between INSO and Madden Julian circulation. Madden Julian oscillation can only be understood when you have fully understood comprehensively the phenomena of El Nino and Southern Oscillation. It's very difficult for a newcomer or a beginner in geography to straightway go into such topics like MJO or INSO and comprehensively understand them. So this will be more useful for the student community which have been preparing for civil services or for geography for last 1 or 2 years. What is Madden Julian circulation, or what is Madden Julian oscillation? Madden Julian oscillation is a pulse of wind which moves from west to east near the planetary boundary layer below the tropopause. So understand that it's a circulation, upper air circulation, which is moving from west, meaning maybe Africa, to Pacific. So this is moving from Indian Ocean to Pacific. Now previously it was thought to be a cold air flow from west to east, a meandering wave-like flow from east to west. However, it is not similar to a jet stream because jet stream has entirely different meaning and mechanism and association with weather and climate. Madden Julian is not even associated with the Walker cell circulation. So I differentiated between 3 things. The Walker cell circulation is distinct, is different, and the Madden Julian oscillation is different. Then the INSO is different and the jet streams are different. So never get confused between all these 4 different phenomena. So I request my students to concentrate really hard today, because we are going to learn one of the most complex phenomena of the tropical region, but this phenomena has massive influence over weather and climate all across the globe. So Madden Julian is a global phenomena. It's not only confined to the Indian Ocean and Pacific. Madden Julian also has been found to lesser degree as a mild phenomena in Atlantic Ocean as well. I will try to simplify the concept and make it very easy for you. So for which I have taken a world map, and on the world map, this is your Africa, this is your Indian Ocean, this is your Indian Ocean IO, and this is your Western Pacific. This is the Western Pacific WP, and this is your Atlantic, and here is your Eastern Pacific, and this will be called West Central Pacific. So we have all these pockets, very important pockets in terms of the weather and climate explanations across the oceans. Oceans are the reservoir of energy. As the insolation is being absorbed by the oceans and being retained for longer time than the continent, oceans become a reservoir or a pool of energy. And they become the engine for all the weather and climates in the world. And all the differences in weather conditions or the variations or the pulsations in the climate are essentially governed by the Pacific, because Pacific is 2/3 of the globe and it covers large area. So it is the heat source for our weather and climate. It drives all the weather condition and the weather phenomena of the globe. Now let's understand the Julian-Madden oscillation. As I said initially, Julian-Madden oscillation is a pulse of wind or a flow of air. It is also defined as intra-seasonal fluctuation of pressure across the Indian Ocean and the Pacific Ocean. So Julian-Madden circulation also involves the oscillation in the pressure system, meaning it creates both high pressure system and low pressure system, meaning anticyclogenesis or anticyclogenetic conditions on one side and on the other side cyclogenetic conditions. So it becomes a kind of three-dimensional circulation, and then it traverses from Indian Ocean towards the Pacific Ocean. So as it travels from Indian to the Pacific Ocean, it brings variations in the weather condition, and in certain pockets you will feel more rainfall and in certain pockets you will have very low rainfall, meaning Madden-Julian circulation or Madden-Julian oscillation will have two phases. A, the phase of suppressed rainfall, and B, the phase of excessive rainfall. So wherever you have the convective system or the cyclogenetic conditions, you will have high rainfall because it is characterized by a number of thunderstorms which are converging in that area, and from the two sides the winds are converging and lifting. So that creates cumulonimbus cloud and heavy rainfall occurs. On the other hand, in the second phase or the other phase, simultaneously you will find that you have anticyclogenetic conditions and the air is sinking, you have more atmospheric stability, and as the cold air is sinking, you will have warming of the air there, and there is no rainfall or the suppressed rainfall. Meaning in Madden-Julian oscillation, you have two pockets, development of two pockets. One is the low pressure, other is the high pressure. And from low pressure, the air is lifting and it is falling at the high pressure. So you have anticyclogenesis at the high pressure point, and you have the low pressure system at the convective points, meaning you have dipole, formation of dipole. So here you have where you have cyclogenetic conditions, you have negative pressure lesser than the sea level. So here you have minus, and where you have more higher pressure than the sea level, it will be plus. So we have a phenomena called dipoles, meaning very inherent to the explanation of Madden-Julian oscillation is the idea of dipoles and the dipole formations. So how it looks like now? Madden-Julian circulation now simply looks like a convective system on one end and a sinking or anticyclonic system, or the area of suppressed weather on the other side, and there will be outflow along the anticyclonic place and inflows along the cyclogenetic places. So we have dipole phenomena here. I can show you on this world map, say during the months of April, March, late March to late May, end of May. So during this period in the tropical region, especially the Indian Ocean, before the arrival of the monsoon, you have formation of high pressure in this zone. Why it is high pressure? Because along Indonesia the pressure is low, minus. Why the pressure is low along Indonesia? Because the trade winds are driving the equatorial water which is going to accumulate near Indonesia, and Indonesia will witness convective system or a strong convective system. So here the air begin to rise, and the same air is diverted towards Tahiti or Eastern Pacific, and another band of air is diverted towards Somalia. So at Somalia the air is sinking, and this is how we have high pressure along Somalia, which we can call the Western Indian Ocean. Now, if you understand this phenomena, how Indonesia will have negative pressure and how Eastern Africa or Somalian coast or the Western Indian Ocean will have high pressure, then we can move to the next stage. Now, as it comes down, the air will move in opposite direction. But since the monsoon phenomena occurs simultaneously, this air is driven towards India, and this is how we will have good monsoon. Now this phenomena where the eastern part of Indian Ocean is having negative pressure and a rise in the sea level because of lower pressure, and the Western Indian Ocean or the Somalian coast which will have high pressure or maybe lowering of this or the fall in the sea level. So this phenomena is also called positive Indian dipole. Now during positive Indian dipole, you will have seesaw in the sea level. So along Indonesia, this is Indonesia is high because low pressure is there, and Somalia or the Western Indian Ocean is having lowering of the sea level. Now that creates a slope. Now as the slope is created, the warm water which was accumulating along Indonesia gradually is drifting towards Somalia, and this warm water accumulates off the coast of Somalia, roughly near 10 degrees south to 5 degrees north. This is the area where the warm water drifting from Indonesia will accumulate. Now as the temperature goes higher in this area, you will have strong convective systems, and when the convection starts, you will have formation of thunderstorms. So here you will have the formation of thunderstorms. These are the thunderstorms in making. Thunderstorms are a kind of a weather phenomena which occur for 24 hours to 48 hours. They are very intense convectional system, and they must die after 24 to 48 hours. So they will have cumulonimbus clouds, etc. And as the thunderstorms are formed, it rains heavily in this region. The rain starts, and the same thunderstorms are driven towards India. The monsoon winds will drive these thunderstorms to India. India will have good rain. But now this area will have rain, India will have rain, but the cold air which is emanating from these thunderstorms, these are the cold air emanating from the thunderstorms. When the convection is taking place, condensation will begin, clouds will be formed, but above the line of condensation you have the cloud formation, but above the freezing line you will have the cold air and the dry air. Now the cold and dry air accumulates, and that is what creates this wave, and this is what is called the Madden-Julian circulation. This is the Madden-Julian wave. But this is not Madden-Julian oscillation. This is Madden-Julian wave which has been created. Now, this cold air, as it goes, it begins to sink. It has to sink somewhere. So wherever it will sink, it will create high pressure. And where it creates high pressure, you will have anticyclogenesis and you will have negation of rainfall. There will be no rainfall. So sometime it falls near Australia, or it falls even over the central or the west central Pacific. So that area will have high pressure. Sometime it can travel even beyond that. Over eastern Pacific it begins to fall. So Madden-Julian circulation will produce a system of such condition where the Indian part, the western part will have high rainfall, and then the western part of Pacific or east of Indonesia, you will have lower rainfall. Now, let's understand a little more, because it is an oscillating system and it is a traversing system. So, as it is traversing west to east, so this high pressure belt will be shifted towards east, and the low pressure belt will also begin to shift towards east. And this whole phenomena of the higher rainfall regime and the suppressed weather condition or the low rainfall regime will begin to drift away towards east, which means Madden-Julian oscillation consists of both the anticyclonic and the cyclonic phenomena, which are found as alternating bands. And Madden-Julian circulation is the wind, is the flow of cold air which is found close to the planetary boundary layer and below the tropopause at an altitude of possibly 1 kilometer to 4 kilometers. What is planetary boundary layer? Planetary boundary layer is an imaginary line above which the frictional forces or the terrestrial friction is negligible. So at the height of 3-4 kilometers, you have very less degree of terrestrial friction. So that helps the cold air to flow smoothly and with higher velocity towards east. Now there is another explanation to it why Madden-Julian circulation is traveling towards east. Because the Earth's angular momentum, Earth is rotating, and the Earth's angular momentum is also being transferred from west to east. So any movement of air above the planetary boundary layer where friction is negligible, it is going to be from west to east. And this is the dipole created by the Madden-Julian circulation. Here it will be minus because of this convection here, and as it falls east of Indonesia, so here you will have plus. So this is the dipole created by the Madden-Julian oscillation, and this negative pressure or the negative dipole will attract wind from this section, from the high pressure area, and the wind is also begin to diverge towards east. So from this anticyclogenetic point, you have divergence of wind, and at this cyclogenetic point, you have convergence of wind, further lifting more rainfall. And look at these dipoles, and this entire system will travel as this Madden-Julian circulation or the cold and dry wind or that meandering wave is traversing towards east. This entire system begin to shift. And as it shifts over Indonesia, now Indonesia will have more rainfall. And as it shifts further towards North Australia can have even more rainfall. So Madden-Julian circulation influences the tropical weather condition in a big way. For better clarifications, I have certain diagrams for you. So you can see the diagram here. This is the diagram. This is what I was talking about. So this part is the negative point or the negative dipole from where the convergent air is rising and you will have cloud formation here, and it is raining in this area, and you will have divergence of air. Now this cold air is diverging in this zone, and the same cold air has begun to sink, and as it sinks, you will have anticyclogenetic conditions here, or plus. So this is how the dipoles are created, minus and plus. That is what I was trying to show you on that on that world map. Now this entire system, what we will call it, this is Madden-Julian circulation or Madden-Julian waves. And what this entire system is called is the Madden-Jullien oscillation. Now this Madden-Jullien oscillation is not a stationary system. It is not stationed. It is moving eastward. But INSO-like phenomena or the El Nino and Southern oscillations are much higher. They have much higher altitude. And then they are a stationary phenomena. Meaning within Walker cell, this Madden-Jullien circulation gradually moves eastward or traversing, or is a traversing phenomena towards east, which will bring enormous changes in the weather condition. As it travels, you will have two pockets with distinct weather condition. Pocket A, which is plus or the positive dipole, you will have high pressure, no rainfall, or the suppressed rainfall. And here you will have very high rainfall because it has a convective system, and it has cloudiness, and the thunder clouds are found. Let's understand further the MJO phenomena. So we have more diagrams for you. Let's see. This is your week 1, emerging over Africa. So this is your Africa. This part is Africa. This is your Madagascar. This is your Africa. Now here the convergence of air, I have explained as to why along Somalian coast the warm air converges, warm air accumulates, and how it creates the conditions for the origin of thunder cyclones or the thunderstorms. So here the thunderstorms are created and it is lifting. This is how it begins. This is stage 1, first week phenomena. Second week May you will find this phenomena, this particular convective system area, it has drifted. Who is driving this Madden-Jullien circulation? Now this puzzle has been resolved by the recent scientist whose name is Fiona. I'm borrowing this map from Fiona. So Fiona has explained that because this cold air is very powerfully moving towards east. Why it is moving towards east? I have explained because of the transfer of angular momentum from east to west. Because of the transfer of angular momentum from west to east, as the earth is rotating from west to east. So this is the driving force of the MJO, and this, as it is driven towards east, look, from Africa it has reached over Indonesia and northern Australia, which is experiencing very high rainfall, and it will further drift and it will again be occupied by the high pressure. So this Madden-Jullien circulation will be created here along the African coast, Somalian coast, or the Western Indian Ocean after 30 days or 30 to 40 days. The books are writing 30 to 60 days, but roughly after 45 days, this circulation again begins, again originates, and it travels towards east, and this is how it produces the alternating high pressure and low pressure systems over the same region. Say I am Australia, so I will experience low pressure or maybe high pressure to begin with, high pressure, and then high pressure moves and the low pressure comes. So this dipole is moving. I am repeating again, the Walker cell will have much higher altitude, and Walker cells are more or less fixed. They are stationed, and they are stationed having very higher altitudes. Within those Walker cell, you have the movement of Madden-Jullien oscillation. Now let's move to the next diagram. It will show you the further drift of this MJO and now it has reached, this MJO phenomena has reached the Central Pacific, and it is raining heavily over Central Pacific, while Australia will have now high pressure. And again, another after 30 to 45 days, the Somalian coast will also begin to have another formation of the tropical disturbances or the thunderstorms or those tropical depressions here, and it will develop this kind of cumulonimbus cloudiness and the heavy rain, and again the formation of the cold dry air running, traversing, traveling eastward, and the system of low pressure will be again driven towards east. So this is what is your Julian-Madden circulation or Julian-Madden oscillation. Now we need to relate Madden-Julian oscillation with the weather conditions found across the world. Now it's a very daunting task, it's a difficult task, but in my classes I completely explain how it will impact the polar vortex of North America, and how it impacts the polar front jet, and how it produces the heat wave in Europe, how it creates the cold wave outbreaks over North America, and the cold winds can reach, the polar winds can reach up to Atlanta, up to even Louisiana. So all can be explained, all has to be explained with this phenomena called Madden-Julian oscillation. Even the dry and wet spells of the monsoon, even the monsoon breaks, they are all associated with Madden-Julian. So the new scientific world has started explaining all these complex weather conditions across the globe with the help of Madden-Julian circulation. The westerly wind pattern over the North Australia, this Australia, and the wind begin to westerly. There should be what? Easterly winds, like trades should drive the wind in this place. Now what happens actually when the Madden-Julian oscillation occurs and it travels, the wind will begin to come from west. So all these westerly winds found at Australia also can be explained with the help of Madden-Julian oscillation. It can also modulate the timing of occurrence of the monsoon, southwest monsoon. It also influences the occurrences and the intensity and magnitude of the tropical cyclones across the world. And now it is also said to be creating or producing a trigger effect for the El Nino. Now all these relationships, all these the complex phenomena of weather conditions found in tropical region and extratropical region have certain connection with Madden-Julian oscillation, which I will be explaining in my coming videos. So please watch me, please subscribe me, and thank you for the day. Love you all.